Yeah, so most of you guys have known me for a number of years, kind of participating in the group here. I just want to, I put this information together both from information I found online, my own kind of personal experiences, and things like that. But I am not a double E. Okay, I'm a molecular biologist, and what I'm going to share with you is information that I've gathered that, as best to my knowledge, is as accurate as possible. Okay, but I'm not a double E, so I just want to qualify that from there. What I'm hoping to do is give the gang an introduction to this topic, potentially show some of the potential around this subject, and then folks can kind of explore it on their own. And folks are always welcome to reach out to me if they have questions. I've been on this journey for a while, exploring this topic, but I'm sure it's by no means done, and I'll just kind of put it forth from that perspective. So this is just kind of what I've been able to put together, some fairly good and what I consider to be accurate information, but I'm not a double E, right? So just bear that in mind. This is just Stephen, the scientist, kind of sharing his experiences and what he's learned kind of on this journey along with the rest of you guys. So, okay, so hi guys, my name is Stephen Scharf. I'm an audiophile like you guys, and I've been was kind of asked to put this. I've been exploring this area we're going to talk about tonight for some time, both as someone who's kind of just been an audiophile, but also a scientist my whole career. So it's been an area of interest to me. I found that what I'm going to talk about tonight really can help the lifelikeness and enjoyability of your audio systems, right? And I think there are sound reasons for that. But again, these aren't absolutes, right? I'm just kind of sharing what I've learned, my experiences, and then hopefully introduce this to you such that you have enough curiosity to explore it further on your own. I'll kind of just put it from that perspective, if that's okay with everybody. So I'm going to share my screen here real quick for you guys. This is the slide, the kind of PowerPoint presentation I'm going to speak to here. And again, I'm going to just go through these slides here. So I'll just kind of preface this, that a lot of what we're going to be speaking about comes out of, the historical, I guess, best practices with respect to, having electricity that powers our homes and things like this, right? And I'm not an electrician, but this is just some information I found from a very good presentation about the electrical environment. And I'm not going to read the slide out. You can read it for yourself, but I think the important thing here is to be mindful of that a lot of the background that we're going to be talking about at some level comes from originally, using, electrical components and systems, and that there's a safety requirement attached to that, right? And as you make, if you make some changes to your system, be mindful that you don't want to create a situation where you compromise the safety of the equipment that you're using. And that's what these first slides are going to speak to. I'm not going to read them out, but one of the key things is you always want to be sure you've got the appropriate safety grounds installed, right? And that your plugs are connected securely and safely, in a manner that conforms to standard safety codes and things like that. Okay, so what is grounding, right? So in terms of electrical power, it's a connection between exposed conductive objects to minimize the voltage differences between them. Electronics is a return path for current. Just a tip here that it always returns towards source, whether intentional or accidental. So, just be mindful of that in terms of as we kind of go forward and explore this area. We have a 3-wire system in the United States you're probably familiar with, where there's basically 2 wires that kind of provide the power. There's a hot and then a neutral, and then there's also, as you know, a green grounding wire that's there for safety purposes, okay? And the neutral and grounding and bonding at each other, and then to earth ground at the service interest or a ground rod in your property or something along those lines. Again, this is just to state again that, we're playing with electricity here, things are at 100 volts, you just need to be mindful that, we don't want to create a situation here where there's a risk for shock or electrocution. So this kind of sums it up, right? Be careful with what you're doing as you explore these areas here. And again, just one last thing: don't use cheater plugs. for your equipment. They're not a way to connect something that, might require, for example, certain types of audio devices only have two, a hot and a neutral, not a ground pin, right? You don't want to use cheater plugs to connect those. The point of this plug here is to provide safety grounding for old style two-prong receptacles, okay? That's the purpose of this plug. So I'll just kind of leave it at that. Okay, so in terms of grounding practices, right, we're going to kind of talk about a number of different terminology here. You guys can read the slide faster than I can speak to it, but basically, we kind of just spoke about the importance of earth or safety grounds, and what I'm going to kind of speak to more tonight is what's known as chassis ground and signal ground, in terms of how that influences, the performance of our audio system here. So learning and understanding some of these grounding practices can really help kind of improve your experience. So historically, it was common to mount equipment in a metal rack, right? And then that equipment, like in radio stations or whatever, would be connected to a common grounding lug or a terminal using braided ground connectors. And probably if you guys had older gear, you may have noticed that back in the day, every electronic device had a dedicated grounding lug for this connection, and this still continues today in telecommunication and networking, right? And typically, components from this time frame use single-ended RCA that were quite susceptible to ground currents, which can result in hum and buzz. So connecting all the equipment to a central ground point ensured safety and eliminated voltage differences between the component chassis that may have caused ground loop problems. So these are just, again, some definitions, right? What is electrical safety ground? That's the in-wall wiring system that we have in the United States. It's the standard. There's 3 wires, a hot, a neutral, and a ground, right? And then the ground wire connects to the grounding rod that connects the entire house to earth ground through the electrical panel. They're also referred to as safety grounds. And they have one purpose: to ensure, in the case of an appliance or electrical component for short, the breaker flips and cuts off power to the outlet, right? And again, don't ever disconnect these things. Okay, this is really important for everybody's safety. This just kind of shows a diagram of that, right, at kind of a high level, in terms of how you might connect a piece of gear to your wall receptacle. It goes back to your breaker. Then, it connects ultimately to the power transformer. And for safety purposes, there's a safety ground, earth ground rod somewhere in the earth next to your property or home somewhere. So, and then, as we're probably aware, as kind of time has evolved, a lot of mass market products nowadays no longer have that ground terminal on them, right? Exceptions, of course, are turntables and phono stages, photo preamps, where you need to ground those components to prevent hum from the cartridge during LP playback, right? So while a lot of components don't have a dedicated chassis ground terminal, it's still really advantageous to ground your equipment to a common grounding system. This reduces loop currents and the associated hum and noise problems. And it also improves audio and video performance, even if there are no obvious ground loops or hum. So you can see the benefit of some of the products I'm going to talk about tonight, not only here in your audio system, but you can see it in your video systems as well, right? Because we're taking noise out. I'll just add that, just to kind of move up the ladder of abstraction, right? It's important to understand that there is no signal without noise. You can never completely get rid of noise. What we try to do is reduce the noise floor as much as we practically can, so that we can, hear as much of the signal of the total system components, okay, from the electrical amplification or video, reproduction. So just some terms for you guys. What is chassis ground? That's the primary or first grounding system of a component. It exists as an extension of electrical safety grounds. The component has a power inlet with a hot, neutral, and a ground. And if you were to look inside any component, you would see that there's a ground wire connected directly to the metal chassis. It's a green wire according to code. And again, it's generally as short as possible inside the component, making that connection directly to the metal chassis of the component, right? And this is in the case of a fault where a live wire touches the case. This ensures the current shorts out or is grounded to the safety ground, flipping the breaker. The term chassis ground typically refers then to the metal enclosure of an electronic component. And again, I just spoke to this. It has an internal wire that connects from the AC cord to the metal chassis. And that chassis then is an extension of safety ground, right? And the NEC electrical code requires this connection, and it is critical in preventing electrocution or potential fire hazard in the event of a fault. So if a wire were to come loose with an appliance and touch the metal case, it could potentially electrocute someone that touches the appliance. And the safety ground ensures the current is diverted, that is shorted back to the electrical panel, causing the breaker to open. That's the role of that short green wire. I'm now going to kind of move into more about how we think about ground system architectures for our stereo systems and components, okay? This is a fairly detailed slide, but basically what you see here, and you can, I'll make the slide deck available. Jim will work out some way where folks, if they want, I can send it to them after the talk tonight, right? They can download it as a PDF. I actually have it saved as a PDF already, so folks can just get it for reference later.
That's fine, yeah.
Yeah, point here is that, well-designed components have a chassis ground terminal that makes a star ground connection that ultimately makes a connection to earth ground, okay? And again, these are just, good best practices for electrical components of all sorts, right? There's three basic methods to check, a connection to chassis ground, right? If you've got a dedicated ground terminal, right, then, you don't need to do continuity tests. Some components have ground terminals. Like one of the reasons I like Lumen is they put a proper ground terminal on all their components. Other companies do, but it's more common these days that they're not there. So the second method would be to locate a chassis screw that has continuity to the component's ground pin within the AC power inlet connector. And then you use an ohm meter and you measure basically between, say, that chassis screw and the center pin for the IEC receptacle to make sure that it's less than 1 ohm in resistance, right? And then the third and last method, if the first two are not practical or possible to do, is signal connectors such as RCA outer barrels or XLRs have a direct electrical connection to the component's chassis. And again, you can use an ohm meter to test that, to see that it's making a true connection to what is known as chassis ground, okay? So this is an example, again, of what's called a bus grounding architecture, right? It's somewhat different than a star grounding in that it consists of a long wire or braid. The components are then connected with short taps to the longer bus cable, which you see here at the bottom, and then that makes then a connection to earth or safety ground. There's another term we're going to talk about a little bit this evening as well, which is signal ground, and that's actually a different thing. And the reason that there's some confusion between them is the word ground appears in both types of descriptions or contexts, right? So safety ground and chassis ground, are commonly misunderstood, leaving signal ground, are commonly addressed. We kind of just spoke to what that is. They make a connection ultimately to earth ground. But basically, signal ground is essentially the 0 volt reference point that an electrical engineer kind of uses to reference the voltages within his components, okay? And that's what this point here talk about the circuitry inside the component. If a preamplifier is designed to amplify a signal from a source component, it will send that signal to an amplifier. Internally, the preamp has a power supply which generates DC, which is modulated, and then an amplification stage has a signal input and signal return, which is often called the signal ground, okay? So this is the second grounding system, okay, that we kind of refer to and manage with respect to our audio systems, right? It starts with the component's power supply reference ground. It includes the printed circuit boards, the circuit bound ground traces and ground wires, and it includes the return paths of the various signal input and output interfaces, right? And so the interconnecting wires, the interconnects between your amp and your preamp, or your preamp and your DAC, they are part of the signal grounding system as well, okay? Once you connect all your devices together, they're connected by the interconnects, and so they share noise across all of them. The noise is not independent to any given component within your system. It gets shared across all the systems, all the components within the system. Okay, so this signal return is generally the ground of the DC power supply. Engineers will commonly refer to this as the 0 volt level. This ground reference plane may be different from the potential voltage of the chassis ground itself. They may not be the same, okay? So it's important to kind of treat these differently. We're going to talk more about that when we kind of get into some of the approaches for reducing chassis ground plane noise versus signal ground plane noise. And we'll talk about that in a few minutes here. So why does this matter to audiophiles? Well, it's because the amount of noise exists even on the safety ground in the wall receptacle, okay? And each one of the components itself generates noise, which many engineers will direct by design to the power supply ground. This then pollutes the ground plane of the component with noise. And then to compound and exacerbate these problems, right, they're connected oftentimes with many types of different connectors, RC, XLR, USB, Ethernet. All of these connections will add some level of noise to your overall system noise floor, as it were. Okay, so, this type of noise is not always obvious. It's just hum, buzz, or hiss or buzz. A lot of these high frequencies interfere and cause distortion within the components themselves. And then this decreases the resolution and clarity of the component performance by raising the baseline noise level and smearing signal transients, okay? So a properly designed and deployed signal ground system can significantly improve your overall system performance, reducing perceived noise, refining dynamics, improving resolution, and also, I think, creating a more lifelike listening experience as well. So I'm just going to diverge here for a moment, and I'm going to speak to kind of some other approaches that you can use to remove ground plane noise. But you can do some simple experiments to play around with this yourself that are really cheap and easy to do. And one of the ones that I did some years ago is I simply took some of these closed circuit TV RCA connectors that have a minus and a plus terminal or a little input on them, and connected a copper green, pure copper ground wire to a copper split bolt. Okay, so you can see that each one of these guys is connected to this split bolt, and you can plug those little RCA connectors into an unused RCA input or output of, say, your preamp, and try and see what you think of that in terms of what that will do. In my case, it made the noise floor go down a little bit, okay, because we're kind of taking that noise out of the circuit topology, right, and shunting it to ground. Okay, so this is a really simple tweak you can try for yourself, see what you think. The other thing is, you may notice that well-designed components, such as Ether Regen, and Ether Regen was designed by John Swenson, who's a really, really, really good Ethernet professional engineer. Many, I'm sure, are familiar with Ether Regen. John's a very good double E. And what did he do? He put a proper ground terminal in Ether Regen, okay? Which is really cool, because if you have an Ether Regen and you connect a wire from the ground terminal to a chassis ground connection, you will very likely hear an improvement in how Ether Regen sounds. That's why John put it there. I'm going to speak to the products that I know the best. This is not an advertisement. This is me speaking to this company's products that I own and use. But Shinyata Research has kind of paved the way with their Altera products to really address this previously unaddressed approach to minimizing ground plane noise, right? And I'm going to talk about how they have two approaches to do that, right? But it's all comes from a deep understanding by Kalen Gabriel of the physics behind this, okay, and how to best design components, passive components that really take the noise provided by, that is instilled by ground plane noise, both chassis and signal, into our systems, okay? And again, I'll just reemphasize, there is no signal without noise. There will always be noise, right? This is just the physics of it, okay? At the very, very lowest level, there's always going to be shot noise, because that's how physics is, right? So whatever you can do to lower the noise floor, will improve the experience of your listening to music with your components, right? So properly designed ground system starts, again, with safety and electrical panel ground. You ensure the grounding rod and the panel are properly connected to have low impedance to earth ground. You generally need an electrician to help you with that. And it's important to have quality AC outlets for your audio system, right? Most AC outlets in homes are cheap, 50-cent outlets. But for audio and video, you can replace those cheap commodity outlets with high quality commercial AC outlets that are designed for audio applications. And it also helps to produce system noise. So Shinano makes one called the SRZ1. You can purchase. Furtek makes the FBX and GTX, and AudioQuest makes the Energy AC duplex wall outlets. So you can play around with that. My experience is they make a notable improvement. Not huge, but you can hear the improvement that using these higher quality AC receptacles to replace the cheap generic ones can provide to your system. Okay, so when Kalen developed the Altera products, he took kind of a three-level approach to developing a set of products that reduce the various classes of ground plane noise. And the first one, what's known as the chassis ground system, right? And this is to, again, reduce the effective chassis ground plane noise. And I'm going to talk about signal grounding in a moment, but basically this is the place to start if you want to explore this range of products. And you can kind of think of this as the base of a pyramid that's foundational to improving your audio systems in a fairly significant way. So this is just a photograph of an Shinano Altera chassis ground hub, right? This is a photo that I took of my own, actually, just because I like doing product photography, right? So it's a passive device, and then it's got terminals on the back that allow you to connect your stereo components to this particular ground plane hub. You then would connect this with another ground cable to, say, a power distributor that has a proper ground plane noise reduction system on it. So, for example, the Shinano Denali, Everest, almost all of the power distributors have a ground plane terminal on them, and you would connect your Altera from that to your power distributor's ground plane noise reduction terminal on the back. This is not the AC terminal. This is a specific terminal for connecting these devices. So, so in terms of using these, right, the first one is just to use an aforementioned chassis ground terminal. If your component's got one, great. You know, this is, again, why I like Lumen's products, is they put a proper ground terminal on their products, right? And if you've got a terminal there, right, you don't need to do the continuity tests, okay? If there's not a dedicated ground terminal, then you have to kind of go through the protocol that I just outlined to locate a chassis screw that has continuity of the component's ground pin within the AC power inlet connector. Again, you have to use an ohm meter. You need data to do this safely, okay? If it measures less than 1 ohm, then you can use this screw to connect one end of the grounding cable using a very small thin spade or ring terminal that slips under the screw, and then you can connect that to an Altera or Gemini. We'll talk about Gemini a little bit later. It's a similar product. It's a combination power distributor and ground plane noise hub. And then the last method is if you can't use a chassis connector, which is better, you can also use unused signal interfaces. Okay, so RC or XLR have a direct electrical connection to the component's chassis ground. Again, you need to use an ohm meter to check that it's making a proper connection, right? If it reads less than one ohm, you can use that unused signal interface as a chassis ground connection for that specific component. Okay. So using this system, ideally, you want to connect as many components as your system to these ground hubs as possible. And for everyone you connect, you are going to hear a concomitant reduction in the noise floor of your system. The system is going to sound more engaging, more natural, quieter. It's just going to be a much more involving experience, right? And again, you know, unfortunately, a lot of components these days don't have these things, so you may need to use those alternate methods that I just showed in the previous slide. And again, you want to do that component continuity test to determine the best method, you know, both for functionality and safety purposes, okay? So this is just a slide showing the chassis ground continuity test. This would be if you're going to use what's known as a CG or chassis ground Altera, right? You want to check that your component has a continuity to ground. So here you see an ohm meter, right? And you see one of the leads connected to the IEC ground pin, and then another to say a chassis screw on the bottom of the component, right? And it should read less than 1 ohm, okay? And so if you then verify that those components make a proper connection to chassis ground, you can then connect, for example, an Altera chassis ground hub to your preamp, your DAC, your amp, okay, at a chassis ground terminal or an unused signal interface. And again, ideally, if you've got a chassis ground screw in the back, that's the best. But if not, then you can use an unused signal interface with this hub, okay? And I can tell you that you will really hear what your system sounds like when you take all this noise out of it. Okay, so there's another approach that's referred to as the signal ground system, okay? This is really similar to the chassis grounding. Again, signal grounds have to have a common connection point or signal grounding hub. And it should not be the same as the chassis ground, but a separate and distinct hub, okay? And it should not be connected to the component's chassis like the chassis ground hub, but rather one of the unused signal interfaces, Open RCA, XLR, USB, Ethernet, AE, SEBU, right? Those are the types of interfaces you would connect to an SG hub, okay? You're going to see in some slides in a few minutes, you can do a mix and match of these if you want. You can have a chassis ground hub for, say, your amp and preamp, and then for your DAC or your phono stage or your clock or whatever, you can use an SG hub and reduce noise further, okay? So again, this is how, if you're going to use an SG hub for a component, say, such as a DAC, you're going to check that you have signal ground continuity between the IEC ground pin, receptacle ground pin, and the interface, whether it be RCA or XLR. You need to verify with data that it is less than 1 ohm before using these products. Okay, so this is a picture of the Altera signal ground hub from the back. It looks just like the chassis ground hub. In this case, they code the terminals on the back white as opposed to black, so you can distinguish between the two. Okay, and these cables coming in could be various cables from, say, your source system, your DAC, your clock, your phono stage, your preamp, whatever, right, can all come in here. And then you can see off to the right, off to the left here, this then makes a connection to, say, a Shinetta power or similar power distributor that have a proper, earth ground terminal connection at the power distributor, okay? Okay, so you can then expand upon these hub configurations using these SG hubs, where basically, this shows a more advanced grounding architecture where you can have your digital component stack, right? So you can have your DAC, your disc player, your streamer, network player, or your master clock, each connected to a terminal, right? And everything you connect, you're going to hear a concomitant decrease in noise and less garbage and grunge in the presentation. Again, you can never get rid of noise completely, but whatever you do to eliminate it and attenuate it, you will basically hear the benefits that provides.
Stephen,
yes, go.
Question. Go back to the last slide.
Yep.
So I just want to confirm that you can use a device like an Altera to simultaneously reduce ground noise on both chassis ground and signal ground. You don't need a separate device for each. You can have a chassis ground and signal ground all being shunted through a device like the Altera.
Yes, and basically, the terminology is a little bit inaccurate in the sense that, one's called SG and one's called CG, right? Chassis ground, signal ground. The only differences between them is the type of ground plane noise filtering that's utilized between the two. Don't ask me how they're different. I don't know. All I know is that they're different. And basically, if you're going to use an Altera for your entire system, for everything, DAC, phono stage, preamp, amp, get a CG hub if you want to segment your system and you want to kind of divide and conquer source components from amplification components or digital components. I'll show a slide to this in a moment, to analog amplification components. The guidance is to use multiple SG hubs, okay? So, and Jim points out there, you can see a connection from a DAC earth ground to this SG Altera, okay? Again, it's a safe connection. The only difference between the CG and the SG is the type of ground plane noise filtering that's done, but I don't know what that difference is, okay? So here's an example of my ether regen, right? Thank you, John, right? He's got a ground terminal there and I'm running a ground cable, Venom ground cable from that to one of my Alteras, right? And you can clearly hear the benefits of simply connecting this ground wire from ether regen, to an Altera, right? It's not subtle. John's a good engineer. He knows what he's doing. That's why he put it there. So one of the nice things that's really nice is that you know how to make different types of tails available. So unlike other manufacturers, you don't have to buy different cables for every type of interface that you may have now or into the future, right? So you can basically buy a base cable with bananas at either end, a ground cable, okay? You can buy a base ground cable with bananas at either end, and then you can simply get these different grounding tails and snap on at this end, this gold end, this female banana connector, the various types of signal interfaces that you need for your application, right? So you can see one here. There's an RCA, here's an RJ45 Ethernet, here's an XLR ground tail, both male and female, for unused, say, ports on your XLR preamp, you know, that you're not using. Here is a USB-A termination, and here's a BNC, right? So it's really nice in that it's flexible, it's interchangeable, you can change it as your needs evolve. You don't need to buy the base ground cable again. You can just snap on a new tail, okay? Which is really cool. So here's some photographs showing in my application, right? I have an RJ45 tail snapped onto the base cable here, right? There's the banana that would go into the back terminal of the Altera, right? And then here is a USB-A tail snapped on to another Alpha V2 ground cable, right? So this is really nice. It gives you a lot of flexibility, and it's expandable as your system evolves, the terminations of your system changes. You don't need to buy the base cable again. You just need the appropriate new tail for your application, which I think is really cool. So one of the things you can also do is you connect your signal ground hubs to your chassis ground hubs, okay? But you don't want to connect the signal ground hub to a component's chassis and likewise, right? So don't use a chassis ground hub to make a connection to signal ground using an unused RC or other connector. Don't mix the two. Be sure that if you're using a chassis ground hub, you're making a proper connection to chassis ground, okay? If you're using a signal ground hub, you can use that to make connections to signal interfaces. Okay, that's important. There's a lot of literature at the Shunada website. There's tons of brochures and stuff that explain this. That's why I have the footnote here. You know, work with your dealer that is certified to do Altera installations. You can refer to the brochure, but you got to do this right for both, you know, safety purposes, but also efficacy of your installation, right? So again, you can use these together in a segmented system. Just make sure you're making the proper connections between SG connections, single ground connections, and chassis ground connections. So this is, again, another slide kind of showing how you could use these, right? So here you've got basically two signal hubs, one for digital components of your system. You can have your analog components connected to a signal hub as well. And then your amplification components, your amp and preamp, right, you can connect to a ground hub. And then you'll note at the 7th terminal of each of these Alteras, they're connected together. And then that connects to the ground plane noise terminal on your power distributor as well. So you have to make these connections ultimately to your power distributor's ground terminal for this to work properly and safely. Okay, this is critical. And then, you know, if you want to get really wild and crazy, you can set up dual mono segmented systems where you have dedicated SG hubs for the left and right channels for your amp and preamp, right? This is a dual mono signal ground zone, right? So you can basically connect, you know, if you've got mono blocks, you can connect an unused signal interface from your mono block to an SG hub, unused interfaces for your preamp. If you've got dual mono preamps, you can do the same thing, or a single preamp. And if you've got a dual mono DAC, you can also make comparable connections to each channel's Altera. And I've actually got this set up for my Constellation integrated amp. I basically got dedicated SG hubs for the left channel and the right channel. I was a little skeptical of this, but I tried it, and it was just like, holy smokes, right? So this really results in a fairly significant improvement in terms of the presentation quality and the reduction of noise. There's lots of very, very, very good safety worksheets and continuity test worksheets that Shunada has put together. You would work with your dealer on this, and they've got very clear guidance on how to make these connections both safely and properly. So you've got to use these continuity test sheets when you configure your system for safety purposes as well as for, efficacy, ensuring that you're doing the right thing. All this literature is available. These documents are available for configuring a system as you put it together. So, right. So just again, a caveat, just to be clear, when referring to connections to an RCA XLR channel, we do not mean you connect to a normal interconnect to the component or the other end. So you cannot use a regular RCA cable and do this correctly. You have to buy specific Shinyata RCA or XLR ground cables to make these connections to signal interfaces. Do not use a regular interconnect, okay? Do not do that, okay? It's critical. Use the Shinyata proper cable for making these connections to it, say an NSG Altera, okay? Never connect a ground cable to a speaker's input terminals or an amplifier's output speaker terminals either, okay? So do not make your own, right? Unless you're absolutely sure you know what you're doing. So I'll make this slide presentation available to you guys. We'll upload it to the site. There's a really great introduction video on this. And then there's some references here for you guys as well. There's a decision tree, a profile guide, cable worksheet. The URL is all there for you guys for reference. And that is it. So that's kind of an intro to, thinking about how to reduce ground noise.
Excellent presentation, Stephen. Thank you.
Sure.
We have a number of questions in the chat, but I want to start off asking, early on in your presentation, you mentioned kind of a cheap and dirty way someone could try reducing, chassis noise, right, with the wires and a split bolt.
Mm-hmm.
There a inexpensive way to play with reducing signal noise in this?
Okay, so these are AV connectors, okay, audio visual camera CCTV connectors, okay, closed circuit TV RCA connectors, okay. You'll note with this copper split bolt that this green wire only goes into the minus terminal, okay, of this RCA connector. I have no idea how you would do it for XLR. I have limited experience with XLR. But if you have single-ended, you can basically take an unused signal interface, okay, but just be sure you only run one wire to the negative connector of the RCA barrel and then that to your copper split bolt, okay, and see what you think, okay? So you can do that safely, okay? As for XLR, I don't know how you would do it. I imagine you could, if you could get a connector that only makes a connection to the ground pin of the XLR terminal. I don't know. I don't really have much experience with that, but this is a safe way to do it if you've got single-end connections, right?
And using this homebrew system, this reduces signal noise, but does it also would it also reduce chassis noise? Or again, it
would reduce signal ground plane noise, okay? So, again, play with it and see what you think. Again, even if you get, for example, you get that little wire in a copper split bolt and you make a connection of that copper split bolt to a chassis fastener that makes a verifiable connection to chassis ground by testing it at the IEC receptacle,
right?
You reduce the noise as well. So, you can play around with this. This costs $5 to kind of put together. You can order some copper split bolts on Amazon for a couple bucks. You can go to the hardware store, get some copper wire, see for yourself. Just be sure that when you're connecting those single-ended RCAs, you only connect to the negative terminal of those CCTV connectors, not the positive one, okay? Because that outer RCA barrel does make a connection to chassis ground ultimately, even though it's a signal ground interface that ultimately makes a connection to chassis ground inside the component, right? And then you can also get like those little type of ring style terminations, right? Those little things, you can put that on the end. And if you have to verify if you're going to do a chassis ground connection, that screw makes a connection to chassis ground, less than 1 ohm on a multimeter, right? In some cases, if there's paint on the component and you try to put that little ring terminal right on to the split bolt, because of the paint, it may not make a connection to a Zurich, less than 1 ohm connection to chassis ground, okay? So you may have to take the paint off a little bit if you want to, right? So this is why you have to verify with data that you're making these connections properly.
Very good. And Jim Hutton makes the point that on XLR, that pin one goes to ground.
Yeah. And again, I showed a picture of the Shinyata XLR connectors for use with Alteras. Those XLR connectors, the male and female, the only thing that's connected inside of them is pin 1. The signal connectors are not connected to, there's nothing connected there. That's why you've got to use, when you're making those types of interfaces, you've got to be sure you're making the correct connection using a Shinyata, say, XLR tail, right? They have those specially made so you can make the proper safe connection to chassis or signal ground with those connectors. Do not use a conventional XLR signal interface cable or RC. Do not do this, okay? You got to be really careful about this. I can't emphasize this enough.
All right, I'm going to run through some questions and stats. First question is there any advantage for using STAR versus other methods for device grounding?
STAR is a great way to go. A lot of components are STAR grounded. So I don't know. Again, I'm not an electrician, right? You should ask a professional electrician or an AV guy, whether STAR, the guys that do, audio, visual, or TV guys, whether it's an advantage versus STAR versus some other method. I don't know. I haven't done it, right? But STAR grounding is an appropriate way to, my understanding is STAR grounding is an appropriate way to do this. But how you would exactly implement it, you should talk to a proper electrician as to how to do that.
Yeah, the reason why I asked the question was you did mention early on the difference between, or you showed STAR and you also showed bus. And bus and STAR are different. And I just was wondering how different and why.
Ask an electrician.
Thank you.
Yeah, fair enough. All right. In using an Altera without going to another device like a Denali or something like that, then, right? So because you can use an Altera by itself and then just ground to something else, or
so you can use an Altera by itself if you buy the Shinyata cable, the specific cable that connects the 7th terminal to the IEC ground pin of a wall receptacle. They make a special cable for that. Be sure you buy the special cable that is specific for making the proper safe connection to the IEC ground pin of a wall receptacle. Do not.
But it is possible.
It is possible.
You can have to buy the whole system in total.
You don't have to buy Denali or Everest to do this. It will be better if you do, but you can make a direct connection to a wall receptacle, okay? But you have to buy, again, I can't emphasize this enough, you've got to be safe with this. You've got to contact your Shinyata dealer and have them sell you the proper connector from the 7th terminal to an AC wall receptacle or wall outlet, okay? It's wired in a very specific way.
Stephen, I raised this in the chat, but I figure I better talk through this one. Yeah. And it's, if I look at an individual component, be it a preamplifier or other device, what is the difference between chassis ground as it applies to the circuit within the device versus signal?
Signal ground is basically the reference zero voltage that the EE sets, calling whatever this voltage is, I'm calling this zero with, for all the other components measured against that. Chassis ground is a connection from a proper connection from the component's chassis to the ground of an IEC receptacle.
So let's say the power supply is likely to.
I don't know. I'm not a
okay. Okay. Yeah, so it's a design thing.
Reach out to the folks at Shinyata or your dealer about those questions. Okay. I don't know.
It doesn't help. Yeah. Okay.
Contact Richard at Shinyata, or one of the folks.
Only because I raised that only because I've run into unique and interesting problems with a particular product brand called Spectral, which abhors any touching anywhere near.
Right. Yeah. And Spectral does their own thing.
I
Okay?
know, it's so
I
crazy.
don't know what it is, and I can't speak to it, and I'm not going to speak to it.
I know.
Okay?
It's just a warning to people who are thinking about any of this. Take your comments into serious advisement. As an example, my amps have to be floated, even though they're connected to the rest of the system, including the Everest. So
right.
that's just buyer beware.
Right. Again, this is why you need to work with a properly certified dealer to implement these devices safely and properly. I can't emphasize this enough. Okay, you've got to, and the dealers do get certified by Shinyata for installing these applications. They just can't be a Shinyata dealer. They have to be trained properly as well. And then when they're verified as being trained properly, then they are allowed to help customers with their specific application needs.
I did notice if you go to the Shinyata site and you look at the latest grounding cables, they're now up to version 3. And I was wondering, because they don't specify what the hell changed between 1 and 2 and 2 and 3.
They don't specify, right? All I can tell you is that they are an R&D based company, and they're continually working to improve the functionality and quality of their products, like any good R&D company always is. Okay.
We have a question here. What is the difference between a Shinyata grounding hub and a 5-cent wire nut? So if you're going to say using, an Altera with an Everest is a 10, I mean, are you getting a 1 or a 2 or 3?
I don't know. I can't give you a number because I don't know what's in your system, and I don't know what
Fair enough.
Okay? I don't know. All I can tell you is that from that example that's copper split bolt, you will hear a difference. It will not be of the magnitude that you get with an Altera. The degree of the magnitude I can't speak to because I don't know your specific application, and I'm not a double E.
Sure. No, that's very fair. I just reading off the questions.
And to chime in, I have a streamer made by Grimm that seems to be immune to anything you throw at it. Whereas there are other devices, like you said, that I have, like you, the Ether Regen. Huge difference.
Yeah. Again, you're going to get different double E's using different approaches based on their knowledge and wisdom and expertise to solve these common problems in different ways. Okay. This is why you need to work with your dealer to determine the proper application that best meets your needs for your system.
Right. Any other questions out there? We do have one just comment that someone just got the Shinyata ground cable arrived today. Well, happy birthday or happy celebration or whatever. I'm sure you're going to have fun with that. Are there any other questions amongst the attendees today for Stephen? You can unmute yourself. You have a question.
Just a comment in passing. Spectral isn't all that weird as far as floating the chassis ground. There's lots of double insulated gear. My Marantz reference gear connects the third or green wire in the power cord only at the plug. There is no connection to the chassis. So there's a variety of manufacturers that are attempting to isolate noise by floating the chassis. And I think that's all the more reason, if you're pursuing something like Shinyata, to work with somebody that's been trained, because you're making a connection in a situation where the manufacturer has purposely broken the connection.
So that's very sage and wise advice, Brian. Again, work with your certified dealer for your specific applications.
And the last thing, just to save you all from potentially killing yourself or frying your equipment, be extremely careful about adding a ground rod to the earth and grounding your system separately from where your whole house or apartment is grounded at the panel. Some really bad things can happen. So do consult an electrician. You can talk about things like an isolated ground. If you think your house line has a noisy ground, you can ask an electrician about an isolated ground. But dear God, do not pound a copper rod into the earth outside your window and connect it to your system, because the first time there's a voltage differential between PG&E and your expensive gear, you're going to blow it up.
Thank you for that.
Beyond repair.
Exactly. And thank you for speaking to that, because I think in the slides that I presented, it spoke to that at some level, or what some of the slides that I saw spoke to that. So that's a very, very important point. Thank you for making that point tonight.
Don't kill yourself, please.
Exactly.
The other thing is, it depends on where you live as to how well you are truly grounded to earth.
Yep.
If you live in areas that are low moisture ground, Phoenix, Arizona, places like that, you need specialized techniques for laying out your ground and also watering your ground.
Yeah, and this is why as Brian just mentioned, you need to work with a proper master electrician for your application, right?
Yeah, and if you have a 1950s ranch, it's odds are good that you don't have a good ground connection anymore.
Correct.
And finding someone who really understands this stuff is as difficult maybe as finding an acoustician who really understands the application of, what we do in our rooms to the effect of the sound that we get.
Yeah.
So it's tough.
Yeah. John Genova posted something that I think you guys should read. Again, I can't speak to all different electric components where chassis and signal are all at the same potential 0 volts. Again, I'm not a EE. I'm just giving you the best advice I was able to find, online with respect to implementing these applications and my own experience, right? And again, work with your certified dealer. And if you need to make a proper ground connection in your home, either inside or somewhere outside, work with a proper master electrician, with respect to those applications.
I think the big takeaway from this whole session is that, grounding is an important strategy to eliminate noise from your system, and the quest for squashing noise is really worthwhile. Your music will really bloom when you drive out that last bit of grunge from a light dimmer or notoriously noisy motors and microwaves and LED bulbs. It's unbelievable how much crap finds its way into a system, especially if one has a missing ground connection or a ground loop. All this grunge can sneak in and get amplified.
Yep.
and produce distortion, because your amp is reproducing noise that you may not actually hear it, but the amp is working hard, especially if it's a high bandwidth amp like a Spectral.
Right.
It's going to amplify that and get hot and potentially not sound its best.
Sonically to me, it's like we talk about lowering the noise floor, meaning that once you apply these techniques, you suddenly hear more of what was there, because the haze that was there is now gone. Also, the overall sound of the system has great ease, and you feel more comfortable. And this is a sonic in your brain, through your ears, through the system.
Oh, yeah, absolutely. That's exactly my experience. And I just wanted to, speak to Brian's point, which again is really helpful and insightful. Before these products were available, I simply took a copper wire, right, and that copper split bolt, and I connected it to the ground terminal on ether regen, and I could hear the difference, right? And I wrote to an audio buddy, hey, just try this. And he wrote me back, oh my God, like holy smokes. It's like, John put it there for a reason, so.
By the way, years ago, there was a Stereophile article about doing exactly what you recommend not doing. And, quite funny. And I also saw someone a major reviewer doing a tour of their listening room where they did exactly the same thing. So it's fascinating, but I think you at that point prevent the safety ground from operating properly if you create a separate ground rod.
Yeah, I would not advise folks to do that, right? Everybody has to, it's kind of like I used to race motorcycles, right, at Sears Point, and everybody has to decide for themselves what their risk tolerance is for themselves in terms as they journey through life, right? I wouldn't mess with it. There are very good and safe solutions out there, and I'm an exceedingly pragmatic kind of guy. I just go with what works and doesn't break at the end of the day. So
I will say, add in that I was at another of our members' houses earlier this year, and he took just basic grounding copper wire and lots of little alligator clips. And he went around to all his components, and they were all starred in, I guess for a better word, to this one wire. And he cut a little hole in his wall, and that wire went to the one ground, in the rod that was in the ground. So it was the same rod, but the difference between connecting it and unconnecting it, just doing that was extremely apparent. So,
yeah, even that little copper split bolt, makes for me in my case it made an improvement. I think somebody was Manrique trying to speak there. I'm not sure.
maybe not. It might have been background noise. So
One thing that you may want to talk a little bit about, at least in terms of the Shunyata implementation, is that each of those 6 connections are isolated.
Yes.
And in the way I took a quick look at Larry G's quartz acoustic pointer, and it looks like that would be a single similar kind of box that you connect, but it's designed for what looks like not chassis, but the other grounding that we're dealing with. Yeah.
Yeah. So Steve, thank you for that. I forgot to mention that. Yeah. When you look at an Altera chassis from the back and you see those 6 terminations on the back, right? Within each of those zones are completely isolated from, ground plane noise from each other. Okay. And then there's an internal bus of some sort that connects each of them to the 7th terminal to make that connection to chassis ground on, say, a power distributor. But each of those zones are completely isolated from the other. So when you connect, say, a DAC to one and a preamp to another and a clock to another, the noise between all those components is completely isolated one from another.
Also, as I understand it, the signal ground is differentiated from the chassis by the frequencies that it's dealing with. I believe
That's correct.
It's the high frequencies that
Yes.
are the big focus for the signal ground.
That's right. I don't know. I have no knowledge of how the filtering is done from an engineering perspective. I just know that they're different, and they're different in the way you just described. That's correct.
any other questions? We're a little bit more than an hour. It's been a very, very nice discussion. Really good job, Stephen. Thank you.
Sure.
We will get that. I'll work with you to get the slide deck onto
Sure.
our website.
I've got it saved as a PDF so folks can refer to it. We can put it on the website for folks to download. So.